Topics to be covered in this lesson are light, reflection of light, spherical mirror and its types, ray diagrams, image formation by concave and convex mirrors, refraction of light, refraction through glass slab, refraction by lenses, image formation by lenses, and lens formula with power of a lens. So now let us see what would be our objective of this lesson. That means why are we going to study about all these things? So here in this lesson we will be talking about some of the phenomena, some of the properties which are shown by light, right? Now, why are we studying that? Have you ever observed that when you are inside a room where there is no light, for example, you are inside a dark room, the moment you switch on the light, you are able to see every object which are present inside the room, right? So that's the beauty of light. It enables us to see each and everything present around us. We talk of light, when we talk of light, we talk of several phenomena related to light. For example, a reflection of light, refraction of light. I mean, what are they? We are going to study in our next slides. But here I am talking about some of the things which we see around us and which are based on these properties of light. For example, a mirror which we use at home daily. So it is also something which uses the principle of the reflection of light. The spectacles which you wear, or maybe the rear view mirror in your car, while you would have seen that just on the right hand side of the driver's seat you have the rear view mirror so that you can see the traffic which is coming behind. So all these are applications of reflection of light. Not only that, you have these optical instruments like telescope, camera lenses, as well as microscopes. These are all based on the properties of light. Some of the natural phenomena which take place, for example, when you dip a pencil in a glass of water, the pencil doesn't look straight, it looks bent. So these are also due to the phenomenon related to light. The rainbow which you see on the sky just after a rainfall. So all these things, I mean, here I have given you few examples so that you understand that why are we going to study about light. I mean, what is the purpose of studying it, right? So now let us start with what is light. Just now I mentioned light is something which enables us to see everything which is present around us. So it is a form of energy which enables us to see things around us. You all can imagine, I mean, at night when the power cuts off, it becomes so difficult because we're not able to see anything which is around us. Life is so difficult without it, right? Light travels along straight path. These are some of the things which you already know from your junior classes, right? It is always said that light always travels along a straight path. I mean, it doesn't bend. So why was it assumed like that? Because it was because in earlier days scientists had performed certain experiments and they told that light will never bend around the corners. They always travel along straight path. Speed of light is measurable and it is supposed to be a constant value, which is 3 into 10 to the power 8 meters per second. So this much is the speed of light, and it is generally denoted by a small c. So that is the convention which has been used since years. So this was something about light. So now let us talk about light rays and light beam, because that is what we will be using on and off in this entire lesson. So what is a ray of light? When I say, you will see that as we go ahead with the lesson, everywhere I'll be saying a ray is falling here, rays are falling there. So what is a ray of light? Straight line path of light. As I mentioned, that since light travels along a straight line, so just to denote the direction in which light is falling, it is generally denoted by rays. So this straight line path of light is termed as ray of light. And what is beam of light? When you have a bunch of rays of light, you call it as a beam of light. For example, if you have several rays of light, a collection of rays of light, this entire thing will be known as beam of light. So as a matter of convention, everywhere in this lesson we will be talking about a ray of light, phenomenon shown by light that is known as reflection of light. So what is reflection of light? It is the bouncing back of a ray of light when it strikes a boundary between different media through which it cannot pass. Let us suppose you keep certain object through which light cannot pass through. Then what happens? Let us suppose this is my boundary. That is some object through which light cannot pass. So what will happen if a ray of light falls on this boundary? It has no option to pass through it. So what will happen? It will bounce back. So this phenomenon of bouncing back of a ray of light when it strikes a boundary between different media, because it will happen only when it strikes something, right? Because until and unless it strikes something, it will never bounce back. It is something like, let us suppose there is a wall here and a boy is standing here. So he hits a football. So as long as the football doesn't hit the wall, it will not bounce back, right? So once the football hits this wall, it will bounce back. So in order to bounce back, it is necessary that the object hits the boundary. So similarly here also, this boundary is nothing but it is a boundary between two different medium. For example, here it is air, here it is water, or anything, any different medium or whatever. So it should be such that light ray cannot pass through that medium. So it should be an opaque medium. So then what will happen? It will bounce off, and this phenomenon of bouncing back of ray of light is known as reflection of light. So when we think of examples of reflection of light, you can think of all these scenarios. For example, when you see your face in a mirror, what happens? There are rays of light. For example, let us suppose if there is no light at all inside a room, right? So let us suppose even the windows are closed, everything is closed. Will you be able to see your face in the mirror? No, that is because there is no light present at all. But if light is present, you are able to see your image on the mirror. That's because the rays of light from your face are falling on the mirror, but since it is unable to go to the other end, it bounces back. And it bounces back and reaches your eye, and that enables you to see your image in the mirror. So now here also, if you see here, this pot is kept here and the image is observed in the mirror. The same thing is happening. If you look at this is also a natural phenomenon of reflection. Here you have this water. So there is a change in medium. This medium is water and this medium is air. So when the ray of light falls on this boundary between air and water, what happens? It cannot pass through the water completely. It is not that it cannot enter water at all. I will talk about that when we talk of refraction. But the rays of light, when it falls on this boundary, some of it will bounce back. And this phenomenon is known as reflection. And as a result of reflection, you see an image is formed here. You can see an inverted image of the hill is formed on the other medium as well, right? So this is known as reflection of light. Now there are certain laws which this reflection of light follows. So in fact there are two laws which is universally followed by this phenomenon of reflection of light. What is it? The first law says that the incident ray, the reflected ray and the normal all lie on the same plane. So let us first talk about these three terminologies, which is a reflected ray, which is an incident ray and which is the normal. So let us suppose this is my boundary. This mirror is my boundary. So the ray of light which strikes this mirror, since this ray of light is incident on the mirror, the ray of light which is falling on the mirror, that is known as incident ray. The ray of light which bounces back from the mirror. So this ray is the ray which is formed after reflection. So this is known as a reflected ray. So this is my incident ray. This is my reflected ray. And what is normal? Normal is an imaginary line which is drawn perpendicular to the plane of this boundary. So if you see, this is the mirror. This normal is an imaginary line at right angles to this surface, right? So the first law says that these three rays, that is the incident ray, reflected ray and the normal, all will lie on the same plane. So here you can see that they all lie on the same plane. That is, if you look at this figure, you can see that they are all lying on the same plane on the mirror, right? The second law says that the angle of incidence is equal to the angle of reflection. Now, what is the angle of incidence? The angle which the incident ray makes with the normal, that is known as the angle of incidence. So, this is my angle of incidence. So, this angle of incidence is between the incident ray and the normal. Similarly, which is the angle of reflection? It is the angle between the reflected ray and the normal. So that means it is this angle. So it says that this angle of incidence is equal to the angle of reflection. So that means these two laws will always hold true wherever reflection takes place. That is, angle of incidence will always be equal to the angle of reflection, and incident ray, reflected ray and normal all will lie on the same plane. We have talked about what is reflection of light. Let us talk about spherical mirrors. What are spherical mirrors? As the name suggests, what do you think? What can it be? It has to be a mirror, right? Spherical, that means maybe the mirror is spherical in shape, right? That is the only possibility which we can assume from its name, right? So spherical mirror is a part of a reflective spherical surface. That means if you look at this picture here, you have a big sphere which is made up of, which is nothing but a mirror. I mean, you can imagine it is something like it is a sphere. You can imagine any sphere like your football, but that football is a kind of a mirror. I mean, you can see your image on that. Here you can see that the people who are standing here, they can see their images on this, right? So spherical mirror is a part of a reflective spherical surface. That means it is a spherical surface which is reflective. That means which is capable of reflection, right? Okay. Now there are various types of spherical mirrors. The major two types of spherical mirrors are concave mirror and convex mirror. So these are the two types of spherical mirrors, concave and convex. So what is a concave mirror? Concave mirror is the one which is silvered on the inside of sphere. So generally when we talk about this spherical mirrors, these the mirrors which you see, they are concave mirrors and convex mirrors are something which we use in our day-to-day life, but they are not exactly in the shape of a sphere. It is basically a part of the sphere. For example, you see this mirror, right? It is in the form of a sphere. But let us suppose this is a sphere. So you just take a part of this spherical mirror. So what will happen? It will look somewhat like this. It is a part of that entire spherical surface, right? So spherical mirror is basically a part of that entire spherical surface which is reflective in nature, right? So when I talk about a concave mirror, it is silvered on the inside of sphere. That means if you see, this is my concave mirror. Wherever silvered means, which portion is called silvered? Silvered is the portion where the mirror actually is. I mean, in front of which you stand. For example, at your home, you have a mirror, right? When you place the mirror in front of you, the front part of the mirror where you can see your image, that is the silvered side of the mirror. So when I talk about a concave mirror, the inside surface of the sphere is silvered. As you can see here, this portion is silvered, inside part is silvered. So the other part, that is the back of the mirror, is denoted by these lines. This is how we represent a concave mirror. So that means the person, whoever is the object, has to be present on this side, so that this is your silvered portion and you can see your image, right? Similarly, when we talk about a convex mirror, it is silvered on the outside of the sphere, right? So in this case, if you see, if this is a part of a sphere, right? So the outside portion of the sphere, for example, this is a sphere, right? So in case of convex mirror, the outside is silvered. That means the inside is not silvered. So this portion is. So if you look at the diagram which I have here, it is similar to that, right? So the outside portion is silvered. So the object or the person is standing on this side. So you understand what is a concave mirror and what is a convex mirror. So let me repeat once again. Spherical mirror means It is a part of a spherical surface which is reflective in nature. That means which is capable of reflection. There are two types of spherical mirrors, concave and convex. When I talk about a concave mirror, it is silvered on the inside of the sphere. When I talk about a convex mirror, it is silvered on the outside of the sphere. Right? So it is very important to remember which is a concave mirror and which is a convex mirror. Please do not get confused with this. So you can use a memory tip to remember which one is concave and which one is convex. If you remember this word, if you look at this word concave, you have cave in it. Cave means, all of you know, right, what is a cave? Cave means you call it as what you call as gufa, right? So cave means when you enter inside something. So that is what the inside is sphere. So wherever you have this word cave, you have inside. That means the inside is silvered. So that is concave. And the other one, that is convex, is outside is silvered. So now let us look at some of the terminologies related to a spherical mirrors, because now we are going to study about, our objective right now is to study about reflection of light by spherical mirrors. How reflection takes place by spherical mirrors and how image formation takes place in spherical mirrors. So for that we should be aware of some terminologies related to the spherical mirrors. So the first term is pole. What is pole of a spherical mirror? It is the center of the reflecting surface. So let us suppose if I have this spherical mirror. Which mirror is this? Whether it is a concave or convex, the inside is silvered, right? So inside means cave. That means it is a concave mirror. So center of the reflecting surface. This is my reflecting surface. So the center of this reflecting surface is called pole. That means this point is pole. It is generally denoted by a capital P. The next is center of curvature, which is denoted by a capital C. It is the center of the sphere of which the mirror is a part. As I mentioned before also, spherical mirror is part of a spherical surface. So if you look at it, this spherical mirror is also a part of some sphere like this. Correct? So the center of this sphere is known as the center of curvature. So that means for this mirror, this is the center of curvature, that is denoted by a capital C. Next is radius of curvature. So it should be on similar lines as center of curvature. So radius of curvature is the radius of the sphere of which the mirror is a part. So that means radius of this sphere. So this radius would be known as the radius of curvature. Next is principal axis. It is the line joining the pole with the center of curvature. That means this line is known as principal axis. So you understand the difference. This distance is radius of curvature, but this line is known as the principal axis. So the principal axis can extend this way. So this line is called as principal axis, but the distance is this distance. That is the distance between the center of curvature and pole is known as the radius of curvature. Right? Okay. The next one is principal focus. It is a very important term and it is a very important concept as well. So what is principal focus? Principal focus is a point on principal axis where the rays of light incident on the mirror parallel to the principal axis converge or appear to converge. Okay, so there is something important to understand here. So first part you understood that principal focus is a point on principal axis. Okay, what happens then? Let us suppose, for now I am considering a concave mirror. Let us suppose this is a concave mirror. So in your books you have representation like this. So this blue region is same as this, right? So this is your concave mirror. These are the incident rays, right? Because these rays are incident on the mirror. So they are incident rays. And what are my reflected rays? After striking the mirror, they are bouncing back. So these are my reflected rays. Correct? So it says that principal focus is a point on principal axis where the rays of light incident on the mirror parallel to the principal axis. So where is my principal axis? This is my principal axis. So if you see, the incident rays are parallel to the principal axis. When they fall on the mirror, after reflection, there is a point where they converge. So they are all meeting at one point. So this point is known as the principal focus, and it is generally denoted by a capital F. This is my principal focus. So this point was pole, this point was center of curvature, and this is now principal focus, right? So what is principal focus? It is the point where the incident rays, which are parallel to the principal axis, after reflection converge or appear to converge. So in this case, in case of concave mirror, the rays of light actually converge. Then why did we use this term appear to converge? That is the scenario for convex mirror, because in case of convex mirror, what happens when incident rays parallel to the principal axis strikes the mirror, they get reflected in this way. I mean, they get separated away from each other. Here what did you see? After reflection, all the reflected rays came towards each other. They all converged to a point. But in this case, these are my reflected rays, right? So these reflected rays, if you see, they are going away from each other. So it doesn't look like that these rays will ever meet with each other. But if you extrapolate it towards the back, you see that they are not actually converging here, right? Because they are moving away from each other, but they appear to converge at this point. So for convex mirror, we define this point as the principal focus. So that is why when we write a general definition for principal focus, we say that it is the point or the principal axis where the rays of light incident on the mirror parallel to the principal axis after reflection either converge, as in case of concave mirrors, or they appear to converge, as in case of convex mirror. So that means in case of concave mirror, the reflected rays are actually converging at the principal focus, but in convex mirror, the reflected rays are actually diverging, but they appear to converge at, or they are virtually converging at the principal focus, right? Please understand this slide very clearly, because understanding principal focus is a very important concept. So now let us see another important thing. So just now I told something very important. In case of concave mirror, what happens? The incident rays have a tendency that after reflection, they will converge at a point. And that is why concave mirror is also known as the converging mirror, because it has a tendency to converge the rays after reflection. Whereas in case of convex mirrors, what happens? The incident ray, after striking the mirror, they tend to diverge away from each other. And that is why this is known as a diverging mirror. So often it is asked in your question that which is a converging mirror, concave or convex. So you should remember all these things. Thank you once again. So now we will talk about focal length of a spherical mirror. What is focal length of a mirror? It is the distance of the principal focus from pole of the mirror. So now let us look at both the types of mirror. So which mirror is this? So by the time I finish this lesson, you should have no confusion about which is a concave and which is a convex mirror. So here if you see, this is your concave mirror, right? Because the inside is silvered. So for your concave mirror, the rays of light after reflection actually meet at this point. So this is my principal focus, which is my pole, the center of this reflective surface, this is pole. So this distance between principal focus and pole is the focal length. That means FP is the focal length. Focal length is generally denoted by a small f. So in this case, this is my pole, and which is the focus? This is the focus. So in this case also, this PF becomes the focal length, right? So this is the focal length of a spherical mirror. So what are the terms related to a spherical mirror? Pole, center of curvature, principal focus, principal axis, focal length of a mirror, radius of curvature of a mirror, right? So these are the terms which we learned so far. So now let us look at the relationship between focal length and radius of curvature. So that means there is a relationship between F and R. So let us try to see the relationship between F and R. The relationship between focal length and radius of curvature is that radius of curvature is equal to twice the focal length in case of a spherical mirror. So this relationship is true for both concave mirror as well as convex mirrors. So when we consider a concave mirror, it is something like, this is my pole, this is my principal focus, and this is my center of curvature. So what is R? R is this distance, right? That is the radius of the sphere. And what is my focal length? That is this distance, F. So it says that R is equal to twice of the focal length. Now, if you want to prove it, we can also prove this. So let us try to prove this relationship. So let us prove it for concave mirror. However, it will be true for both concave and convex, and you can prove it for both of them. But for now, I am considering a concave mirror and will prove this relationship for a concave mirror. Let us suppose this is the pole of the mirror, this is the principal focus, and this is the center of curvature. Let us suppose this is an incident ray. When it strikes the mirror, it gets reflected, and the reflected ray then passes this way. There is another ray which passes through this center of curvature. Now let us suppose that this angle is theta, this angle is also theta. So what will be this angle? If you look at it, this makes a Z, so this angle and this angle will be alternate angles, so this will also be theta. And what will be this angle? This entire angle should be equal to this angle, that is alternate angles again, so this should be equal to 2 theta, right? So now let us name these 2 points as, let me call this point as A, and this point is already P, and let us suppose if I draw a perpendicular here and call that as B, just for my construction purpose. So now if you look at this figure, you can say from the triangle ABC, if you look at triangle ABC, you can say that from your trigonometry, you can say that tan theta is equal to perpendicular by base. So what is perpendicular? That is AB, and what is the base? That is BC. So tan theta is equal to AB by BC. Now you look at triangle ABF. So in triangle ABF, you can say that tan 2 theta is equal to AB by FB. That is, this is equal to AB by BF. Right? Now here, this angle theta is assumed to be very small because incident rays make very small angle to the principal axis, because the incident rays don't make very large angles. So we can say that theta is quite small. Now if theta is very small, we can say that tan theta is approximately equal to theta. All these things you would have studied in your trigonometry, right? So I am not going into the detail that why tan theta becomes theta when theta is small. For all these things you can refer to your mathematics videos. So tan theta becomes theta. So using that, these two expressions will become theta is equal to AB by BC. That will become my first equation, and 2 theta will be equal to AB by BF. This will become my second equation. Right? So from these two equations, you can say that AB is equal to theta into BC. Here AB is equal to 2 theta into BF. Therefore, we can say that from equation 1 and equation 2, we can say that theta into BC is equal to 2 theta into BF. Right? So theta will get cancelled. Therefore, BC is equal to 2 into BF. What is BC? If you look at it, what is BC? This PB, this length PB is extremely small, right? When compared to this distance BC or BF, BP is very small. So if BP is very small, we can say that BC is nothing but PC, right? Since it is very small. I mean, let us suppose if you have a length like this, and if you add a very small length, so this length is almost equal to this length because the difference is very negligible. So you can write BC as PC. Similarly, you can write BF as PF. Now what is PC? PC is nothing but radius of curvature, that is the distance between the pole P and center of curvature C. And what is PF? PF is nothing but the distance between pole and principal focus, that is focal length. So therefore you can say R is equal to 2 into F. That is the radius of curvature is twice the focal length of a spherical mirror. So this is how we proved it. So, and you have understood the relationship between focal length and radius of curvature. Now this relation holds true for a convex mirror as well. If you want, you can prove it in a similar way for convex mirror also.